So we're just going to finish off looking at our, well, 2-unit probability before we can move on to the fun stuff tomorrow. Conditional probability. So conditional probability of an event A given that B has already occurred. So it's sort of like, when we had the Venn diagram and we had the universal set, but when we were only interested in, what was it? Was it geography or something like that? And so we said, now the geography set will be the universal set. It's that sort of thing. We know B has happened, so that's going to change the probability of A happening. The formula for it's this. So the notation you'll see is just the A and a vertical line B. So that means probability of A given that B has happened. It will end up being the probability of the intersection of A and B divided by the probability of B. That's a way of working it out. Of course, if you're just talking about the number of items in the sets, we can just say, well, the number of things in the set A intersection B over the number of things in the set B. Now, turns out that if that probability actually equals the probability of A, then A and B must be independent events, because it didn't matter that B had already happened, we got the same probability. Another way of doing it is probability of A intersection B will equal the probability of A times the probability of B. So that's a quick way of checking. All right, we've got a mixed language class, French, Latin and Japanese. Oh, that's similar to what we do in Year 7, isn't it? So our Venn diagram describes all the situation there. What's the probability that a student who studies Japanese also studies French? So French, given that they also do Japanese. So according to our formula, all we've got to do is look for how many are in the intersection of French and Japanese, and there's 3 of those, over how many are in Japanese altogether, and 5 and 5 make 10. So 3 in 10 chance of that happening. 2 boxes each contain 4 stones. The only difference is the colour. So box 1's got 4 black stones. In box 2 we've got 2 black and 2 white. So first of all, the box is chosen at random, and then a stone is drawn from that box that we randomly picked. What's the probability that the stone we drew out was black? Well, there's 2 possibilities, isn't there? We could have picked box 1. Now there was a 1 in 2 chance of picking box 1, but then it must be a black stone because they had only had black ones. So a half times 1 or a half. Or, so we add, there's a half probability of picking box 2, but if we pick box 2, there's a 2 in 4 chance of picking out black. 3/4 would be our probability of getting a black stone. Of course, the other way we could have done this one is simply have gone, well, there are 8 stones all up. 6 of them are black. Did it really matter which box? I mean, is it any different to saying, let's put all the stones together and just pick one? And in that case, 6 out of 8, and again, you get 3 out of 4. Part B then, it's not known which box the stone has come from. Now, given that the first stone you drew out was black, and remember, you don't know which box it came from, what's the probability that it came from box 1? So now we're saying probability of box 1 given that the stone was black. So we're looking for the probability that it's black and from box 1 over just total probability of it being black. So black and box 1 we said was, well, that was a half, because half chance of picking box 1, then probability of 1 of being black, over the total probability of being black, which we just worked out, was 3/4. 2/3. 2/3 is our answer for that one. In a particular school, 55% are male, 45% female. Of the male students, 13% say Monday is their favourite day, while 18% of the females say Monday is their favourite. Find the probability that a student chosen at random is a male whose favourite day is Monday. Well, we know probability male, 0.55. The probability they favour Monday, given that they are male, we know is 0.13, because they told us 13%. So we know that. I can play around with this formula to get what we want. Sub in what we know, and what we're left with then is probability that they prefer Monday and they are male. So that intersection we're looking for. So multiply by the 0.55 and we get our answer, 0.0715. Okay, so that's the idea of conditional probability.